All right, hello, and thank you for joining us today. My name is Michaela McShane, and it is my privilege to welcome you to the Startup NASA Feature Series, hosted by NASA's Technology Transfer Expansion Program. T2X expands the tech transfer mission of ensuring that innovations developed for exploration and discovery are broadly available to the public, and includes a focus on entrepreneurial innovation and strategic partnerships that accelerate commercialization. This monthly series is an opportunity for NASA technology-inspired startups to share their experience. This month, we'll hear from Dr. Aaron Goodman of Petra Power. Please note that your microphones will be muted throughout this presentation, and put all questions in the chat box in the lower right-hand part of the screen, and we will answer those in the Q&A portion at the end. Thank you again for joining us today. I'd like to introduce formally our speaker, Dr. Aaron Goodman, a seasoned founder, researcher, and entrepreneur with a passion for developing economically driven solutions to the world's most pressing energy challenges. Aaron graduated summa cum laude from Chapman University with Bachelor's of Science degrees in Physics and Chemistry and a minor in Political Science. He spent 3 months working at UT Vienna on nuclear radiated materials before starting his doctorate program at Princeton University. While working at Princeton, Dr. Goodman focused on ion temperature and acceleration during high guide field magnetic reconnection. He conducted experiments on magnetic reconstruction experiment, MRX, at Princeton Plasma Physics Laboratory and developed an optical diagnostic for use on fusion experiments. And with that, I will turn it over to him to tell you a little bit about Petra Power.
Thank you very much, Michaela, and thank you to the whole team, Hia and Renee as well, and then the whole tech transfer team at NASA, who's been a wonderful partner to Petra Power, as I'll talk about in a little bit here. So also thank you to everybody who's joined us today to hear a little bit about what we're building at Petra Power. My name is Aaron Goodman. I'm the co-founder and CEO at Petra Power. We are a precision manufacturer of reversible solid oxide cell technology, working to generate reliable, low-cost electricity from any fuel. Our technology, which was originally developed at NASA Glenn up in Cleveland, Ohio, is really seen as a critical component in the global conversion from fossil fuels, which are in use today, and cleaner fuels such as hydrogen, which many are pushing for a more resilient and secure energy future. The fact, however, is that we can't make that transition quickly. It's of paramount importance that we utilize fuels in the most economic way possible and continue to provide critical industries and individuals with opportunities to utilize fuels that are readily available to them. And hydrogen simply is not the case at the moment. Our technology is capable of converting fossil fuels such as diesel, natural gas, propane, JP8, and more into electricity with up to 90% greater efficiency than a combustion engine. That same fuel is also capable, that same system, I should say, is also capable of converting hydrogen to electricity more efficiently than a PEM fuel cell. And by using its electrolysis capability, Petra Power can also produce clean and abundant hydrogen to help us make that transition without bearing cost impact on future customers. But this is a very high level goal for the company. And as everybody knows, you do have to start somewhere. For us, that somewhere is focusing on operational readiness and cost reduction for commercial vehicles, such as Class 7 through 10 long haul trucks, RVs, and refrigerated shipping containers, as well as in defense markets. And in both of these markets, fuel costs drive operating costs, and they also set barriers on operational readiness. And both of these markets, defense especially, operational readiness is everything. And being able to utilize fuel more efficiently is an opportunity not only to reduce costs, but also to reduce the amount of fuel that needs to be secured and transported in the field, eventually saving service member lives on the military side. The attempts that have been made to introduce this level of efficiency have been lacking in impact. And I'm talking about things like reducing component weight on a vehicle or improving the aerodynamicy of that vehicle. Those are only improving efficiency by a fraction of a point here or a fraction of a point there. The very large stepwise solutions, such as hydrogen or battery solutions, are simply not up to the challenges of the day. They don't offer the reliability and the operational continuity that's necessary to support these industries. And that's really where Petra Power comes in, is our technology is capable of achieving breakthrough levels of efficiency without sacrificing the fuels that are currently in use, without sacrificing operational conditions for the industry, and without making the end user change any of their daily habits. Our systems, as I mentioned, use the same fuel that's already on board these vehicles. That's typically diesel in the commercial market and JP8 in defense markets. And they convert that same fuel to electricity, but do so with up to 90% greater efficiency than the combustion engines that we aim to replace. We're building these systems to be sold at the exact same price points as existing combustion engines, to use the same fuels as I mentioned, but to be up to 4 to 8 times smaller, 5 to 20 times lighter, and to operate with no vibrational or acoustic signature, as well as no odor. This is all made possible by our patented technology. I won't go too deep into technology here, but it's important to note that this was developed at NASA Glenn for manned spaceflight, and they really did an unbelievable job. And we have taken that and identified the key beneficial areas of that research and translated it into a commercial market. And so those key benefits really are about the material processes, they're about the design of the cell itself, and they're about the manufacturing process. And they're really what allows us to build the most cost-effective solid oxide fuel cell on the market with some of the highest performance, capable of long lifetimes, many thermocycles, and resistant to impurities typically found in fossil fuels. Petra Power was fortunate to acquire licenses for this technology through what I now believe to be a defunct program, but what was at the time kind of a competition called the Space Race, hosted by NASA. And in this competition, there were about 15 patents up for grabs and over 100 teams applying for them. NASA awarded licenses for some of those, but not all of those. We were very fortunate to develop a business plan, a financial model, a path to market, a technical plan that was viewed favorably by the NASA team and led us to the license. Now, it's also, I think, important for us to tell this story because the tech transfer office at NASA is very easy to work with. They're very forward thinking in the ways that they can continue to help the portfolio companies that they've supported through the licensing of the technology that they have. And of course, they want to see these companies succeed because it's mutually beneficial for everybody. NASA ends up with technology that they can hang up and say, look at the impact we've had, as well as the revenue that comes from the licensing agreement. And then the companies exist because of the technology. And so it's a wonderful program that we are very fond of. And all the people at NASA have been really wonderful with us. And so we've actually been able to secure additional patents beyond some of the original work that we had secured, and that's allowed us to develop more rapidly and expand into areas that might have previously been inaccessible to us. Just a brief moment to talk about our team because they're so wonderful. Michaela was kind enough to give me an introduction, so I'll skip myself. Our CTO and other co-founder, Philip Clift, is a master's in materials science. He is really handy with just about everything. He can manage and fix all of our equipment. He pushes our technology forward every day, and he is a great co-founder to me as well. Mark Contos, our CFO, is formerly the CFO of both MITRE and Battelle, so a lot of private-public partnership experience that has helped us both with NASA and some of the other government work that we do. He's also been a VP at Citigroup and a former founder himself, and really brings a lot to the team. And then we have 10 incredible employees that I could use the whole presentation on, but just suffice to say that we've been very fortunate to build a strong team in Northeast Ohio, and we hope to continue to be able to hire and contribute to the economic development objectives of the region. Just a quick word on some of our most recent accomplishments to kind of highlight the ways in which we've been able to take this technology from ideation at NASA to getting closer every day to having a market-ready product. Our manufacturing costs are now what we believe to be lowest in the industry. That's with just those 10 employees and no automation to date. Our cell is performing at what we also believe to be the highest level in the SOFC industry, and that's very much due to the design of the cell, which was originally developed at NASA. Because of these great successes we've had, we've been able to secure just about $9 million in non-dilutive funding from various federal contract vehicles that we are using to develop the technology and bring it to market. So if there is a call to action here, and there doesn't need to be, I'm more than happy to just have the opportunity to tell our story here and connect with some of you wonderful people who are interested in what's going on. But if there is a call to action on the technology side, we're always looking to add smart, dedicated, and innovative people to help us push the technology forward. We're always open to partnering with complementary technologies or to doing co-development with larger organizations, and always looking for better product design, better product development, and getting closer to market faster as we can. We also do have an open fundraising round right now that allows us to do some of the business development and sales and marketing efforts that are not enabled by our existing federal work. And so any VCs, CVCs, angels, strategic partners out there, or any sources of non-dilutive funding interested in this, please do also contact me, and my contact information can be found at the bottom of this slide here. So thank you all very much for your time. I'll be happy to answer any questions that may have come up during my presentation.
Thanks so much, Aaron. I will grab the questions from the chat and go ahead and ask them to you kind of interview style.
Absolutely.
Okay. All right. Thank you, everyone, for dropping your questions in the chat bar. Please continue to do so as we read through the initial ones that came in, and we had a few that were submitted ahead of the presentation. So again, please continue to drop your questions in, and I will begin with the ones that we have so far. So Aaron, to kick off kind of with a more general question for you as a founder, what advice would you offer to other startups looking to enter high-tech or capital-intensive industries, especially when competing with large established players?
It's a great question, and one that I often think quite a bit about. There's a unfortunate reality at the moment that for hardware specifically, there takes quite a lot of money to get to the point that someone is willing to give you money. And so we were only able to bridge that gap by using federal funds, but those are not easy to get. And I would be blind if I were to think that it was all because of our hard work. We did a ton of hard work, but there's an element of luck that quite simply is involved in being awarded anything from SIB or sitter contracts all the way up through acquisition or congressionally appropriated funds. And so bridging that gap is very difficult. I'd say that absent those type of options on your plate for a hardware company, the best thing that you can do is build something tangible. So try to put some of your own money into it, or find a couple friends and family willing to give you just enough to get something that someone can see, touch, feel, or see operate. And sometimes that's enough to bridge you with something like a pre-seed round to get to the point that you have something closer to a realistic prototype. But it's people in this industry do understand how complicated it is, and it's something that I think people are looking into solutions for, but there's nothing clear yet.
Thank you. Yeah, I know that is one of the biggest hurdles to getting started in a hardware-based, really any industry, but especially a hardware-based industry. What were some of your biggest technical or manufacturing breakthroughs that made reversible solid oxide fuel cells viable at this scale?
So I would argue that the biggest breakthroughs came at NASA, right? We were handed a platform that needed quite a lot of work, and quite frankly, still needs a bit of work to get to market. But we were handed something that, achieving the cost breakthroughs necessary, achieving the lifetime breakthroughs necessary, and the fuel acceptance that we target for our markets, it needed the right design. And so we were handed the right design. But for us, breakthroughs are really all about focusing on what we're trying to do. So, everyone at the company, as you might imagine, is quite bright, and they're quite interested in science for the sake of science, as many curious people are. But often we have to shelve very interesting phenomenon because they don't lead us towards our end goal. And being able to focus directly on what's necessary to go from where we are to where we need to be in terms of commercial deployment, without kind of squashing that zeal for discovery is a fine line to walk. And I think it's something that we do quite well at Petra Power, and it's allowed us to make very rapid development in the areas that are most important to commercialization.
Thank you. The next question kind of touches our refers to what types of other SOFC, I think that's
That's
solid
right, solid
oxide fuel
oxide
cell.
fuel
Yeah.
cell.
What other solid oxide fuel cell products you're competing with in the market, and what specifically sets your technology aside? I think you already touched
Yeah.
on that on the presentation, but if you could expand on it.
Yeah, I'd be happy to. So I'll first start out by saying that we believe solid oxide fuel cells as the technology have unlimited potential effectively. And so we're a big champion and a big fan of a lot of our contemporaries in the space who are taking different approaches, and we hope that they succeed because we don't see this as a zero-sum game at the moment. With that said, we are doing things quite differently. So this idea of being able to operate on board of a working vehicle is something that most SOC companies are shying away from because SOFCs are ceramics. And if you've ever held or accidentally knocked over a piece of pottery, you're familiar with how fragile they can be. It takes some work to fortify them for that type of environment. Additionally, as I mentioned, hydrogen isn't really available. So if you're going to attack these markets, you have to be able to utilize the fuels they have on board. And our technology is uniquely situated to utilize diesel, for example. So those are significant differentiators, but as far as market application, really the primary differentiator is the manufacturing cost. And we kind of came into this saying, well, we'd love if everybody adopted SOCs because they're more efficient and it's a great technology. But the reality is that most companies, because of their process, because of their design, have to have a manufacturing cost that is prohibitive to compete with most combustion products. And so we were focused on finding ways to drive that down. And we part of it is in the design itself, but we've also been very clever in creating systems and processes that are efficient and that utilize commonly available materials and still produce a highly effective cell.
Thank you. The next one I think is a follow-on to something you said earlier, that the fuel cell is 90% more efficient than ICEs. Can you state what that efficiency percentage is?
Not exactly.
Okay.
Not because I don't know, but because I prefer not to.
Fair enough.
But nominally, I think people know that combustion engines are limited by physics. The Carnot cycle prevents a combustion engine from ever reaching efficiencies above 55%. But in practice, most of them operate in the commercial sector around 30 or lower. And so you can do a little math to kind of get the general range that we anticipate being able to convert diesel at.
Thank you. What benefits have you found by starting off with NASA patented technology versus creating your own baseline technology to develop?
Yeah, well, I'm not a material scientist. So the biggest benefit that I found was being able to have a successful material-based technology. But if I were to kind of take a step back and talk about it more broadly, developing your own technology is complicated, not just from a technical perspective, but where does the funding come from? And
Mhm.
so, say you're a professor or a postdoc or even a brilliant graduate student, those are really the only three places that you could develop your own technology. I suppose we can lump national labs into there. But if you don't hold one of those positions, how do you develop something? There's a limited set of technologies that you may be able to develop in your own garage, for example, but that's fairly restrictive. And so, if you do fall into one of those other camps, well, who owns the technology? Is it the university? Is it the national lab? And then you're actually licensing it anyway. So the only kind of drawback I'll say to licensing technology versus developing it on your own is that the person who did develop it is not always available to answer the detailed questions that are not covered in patents and filings and data. And so sometimes you do have to reinvent the wheel a little bit, even if you have the IP, something that we faced to some extent in our development process. But other than that, the ability to license technology from universities, from federal agencies like NASA, from national labs, is in my opinion, highly underutilized resource within our entrepreneurial ecosystem. And there's tons and tons of value to it when you find the right partner and the right technology.
Great, thank you. Glad it's been a positive experience. Let's see. What have been the most surprising use cases or industries that have shown interest in your solutions, and how are you adapting to meet their needs?
Also a very interesting question. If I had to pick one industry that is the most surprising to me, it's performance racing. Once I started fielding inquiries, I understood why, because it's all about weight. And, SOCs are so much lighter than a combustion engine. But, it's a very niche market. So when we were developing our business plans, we didn't think too much about it. But there has been some interest there. And in general, our approach is that we have to stay focused on the areas where we can have impact. And so, if we take performance racing as an example, that's not really an impactful market for us to play in. That said, we're also a young company who needs to prove its technology out and generate revenue. So we look for mutually beneficial opportunities. If there's an industry that's interested in us and they're not really on our radar as being an opportunity, but they reach out to us, we'll see, is there a way that we can service the needs of your industry without sacrificing our push as we move forward? And the flexibility of our technology generally makes that a viable opportunity. But it's important that we don't lose sight on what we're trying to do. So we look for opportunities to develop and deploy in places that can use us immediately while we build our commercial products for more impactful industry.
Great, thank you. Let's see. How have you balanced a long-term, well, I think this kind of touches on the last question a little bit, but how have you balanced the long-term vision with short-term goals, particularly when navigating funding cycles, customer acquisition, scaling, and moving into different markets from the original one?
Yeah. Um, I have touched on that a little bit, but to really address it directly, uh, that is a kind of just the job of a CEO. The objectives in 6 weeks are different than 6 months, which is different than 6 years. And in a perfect world, it's a straight path. So what you do for the 6 weeks helps you for the 6 month goal, which helps you for the 6 year goal. But the reality of operation is that that's simply not always the case. And so it's about making the decision that you believe is in the best interest of the company. I'm fortunate to have a great and supportive co-founder who we're able to work together on making those decisions. And when it's appropriate, we're able to bring in our senior staff as well and bring their perspectives into it. But it's really, to us about evaluating the problem set as widely as possible, trying to understand all the impacts of things that we can, and then making the decision that's in the best interest of the company. And a lot of that is about risk aversion as well and risk mitigation.
Thank you. I'm going to go ahead and combine a couple questions here that seem to be asking for, I think, different sides of the same thing. So, barring sharing any proprietary information, can you expand any more on the size? Let me see if I can combine this well. The size of the cell, the temperature of the cell, and the other compatible fuels besides diesel.
Yeah, so I'll answer fuels first because that's the most straightforward one. We really are building this to take any fuel that you've got, from fossil fuels of any kind, uh, with maybe the exception of gasoline, mostly as a market fit, to biofuels, to hydrogen, to ammonia even, although there's not really a market for that at the moment. So we're building to be ultimately fuel flexible, again, with this concept that it's important for us to meet our customers in the position that they're currently at, because if they had a better alternative, they would have switched already, looking at market-driven approaches. Um, Operating temperature, we are classified as middle range for SOFCs. Another place we kind of depart from some of our contemporaries is that we actually don't believe that the operating temperature is a barrier to market deployment. So for example, we don't think we need to reach 300 C operating temperature before we can deploy a product. And then size is small. If you've ever seen an SOFC, an individual cell can be less than a millimeter thick and produce 100 watts in a pretty compact footprint. Ours are more efficient than that, so a little bit smaller. But I can't go too deeply into exactly the size of our products.
Fair enough. Thank you for expanding on that a little bit. Let's see, I think I have time for 2 more questions. Given the quiet odor-free operation of your system, are there niche applications, i.e. medical, aerospace, potentially urban markets that have, where this has been an advantage?
Yeah, great question. So, we've chosen the auxiliary power market as our initial market because the barriers of entry are the lowest and our value is the highest. So you may not think so, but the odor-free and silent operation is actually really important to trucking. Driver retention is the #1 issue in long-haul trucking at the moment. And while nobody is pegging the APU as the primary culprit, it is a part of the equation that, sleeping in a sleeper cab is generally not a comfortable experience. And so we can improve that comfort level. But in terms of the compact nature, I will just take a moment to note that our belief is that the future of power is distributed. The national grid is outdated, overloaded, and represents a significant national security threat. And so we believe that things will go to more distributed. The term microgrid's a bit loaded, so I don't not going to use that here, but more distributed fashion. And so we do fit really well into the idea that, you might have a centralized source of power for a community or for a commercial park. And when you start getting to those levels, the quiet matters because, you can't have in the middle of your community a 10 megawatt turbine that is spewing fumes and making noise and smelling like you're burning natural gas. And so that is an important part of where we go from here. But it's not a place that is easy for a startup to begin their journey. Because if you're talking about grid level power, you have to compete at fractions of a penny per kilowatt, which is really not plausible until you're quite large.
Thank you. We always like to end these webinar segments by asking the speaker if they have any general advice for people looking to licensing federal government technology, or like you said, university technology, just licensing technology in general as a means for starting a new venture.
Yeah, so my #1 piece of advice is go for it, which is not particularly useful in and of itself. But what I mean by that is that it's not uncommon for people to get overwhelmed by what the process looks like. Well, where do I start and who do I talk to and then what do I do? But being very deliberate, identifying what you're trying to accomplish so that you can limit the scope of technology you're looking at, because there are, I don't actually know the number, but I would guess thousands to 10,000 plus patents out there right now that are up for licensing between universities, national labs, federal organizations. So identify what you're trying to do and then be very purposeful about identifying the technology you want, contacting the people relevant, and going step by step. Don't get too far out ahead of yourself. When you build a business, it's incredibly important to think about the future. Absolutely. But if you do so at the expense of what's right in front of you, then you'll never be able to reap that future that you envision. So be very intentional. Don't be put off by or intimidated by the prospects of all the things that need to happen. Solve one problem at a time, and let your motivation kind of be your guide so that you maintain the enthusiasm and energy that you had at the start when things start to get really hard, because they inevitably do.
Thanks, Erin. We really appreciate you taking the time to be here with us today. And thank you everyone who joined us. Erin's contact information was on the screen, and feel free to reach out to the Technology Transfer Office if you have questions about licensing information or technology offerings. All right, have a great rest of your day. Thank you, everyone.